We can solve quadratic equations in terms of x or y, but we also need to be able to solve quadratic equations in terms of sine, cos or tan. This may give us two sets of solutions. For example, 5 sine squared x plus 3 sine x minus 2 is equal to 0 is a quadratic equation which we could write in the form 5a squared plus 3a minus 2 equals 0 if we let a equal sine x. We can factorise it to give us 5a minus 2 a plus 1, or 5 sine x minus 2 sine x plus 1 equals 0. And if we set each bracket equal to 0, we get two linear equations in sine that we then go on to solve. There are several steps to follow when factorising these trigonomic quadratic equations. Firstly, factorise the quadratic. It may be simpler to replace the trig function by a letter such as y until you factorise and then substitute the trig value back into your solution for y after you've factorised. Secondly, solve the quadratic. Rearrange the solutions of the quadratic function in terms of sine, cos or tan, and solve these quadratic functions in the given range. Don't forget to clearly list all your solutions at the end of the question. Some questions may only have one set of solutions. In particular, when a solution to the quadratic equation such as sine theta equals 2 appears, there will be no solutions from this, as sine theta can only give us answers in the range from -1 to 1. So the only set of solutions to the trig equation will come from the second quadratic solution. In several of these questions you may have to use the trig identity sine squared theta plus cos squared theta equals 1. If we look at the first example, we're asked to solve for theta in the interval between 0 and 360 degrees. The equation sine squared theta minus 2 sine theta plus 1. So we've got a quadratic trig equation, sine squared theta minus 2 sine theta plus 1, which is equal to 0. So if we let sine theta equal y, we can write this equation simpler as y squared minus 2y plus 1 equals 0. So all I've done here is substitute sine theta for y. I can now factorise this quadratic to get y minus 1 bracket y minus 1 is equal to 0, which gives me the repeated solution y is equal to 1. But I know that y is the same as sine theta, so I'm going to substitute that back in. So I get sine theta is equal to 1. And now I've got a trig equation that I can solve. So theta is equal to sine minus 1 of 1, which is equal to 90 degrees. But I've also got a second solution in the range, possibly. So if I draw my graph, so I've got the graph of sine theta, and if I find 90 degrees and go up to my curve, and then I draw a line across from this point, I can clearly see that there is only one solution to sine theta equals 1 in that range, as it's the maximum point of my graph. So in this question, I've now got a translation. So my range I need to change and add 20 to each limit. So my range for theta plus 20 goes from minus 160 degrees to 200 degrees. And now I need to solve my equation to find all the solutions in this range for theta plus 20. So cos squared theta plus 20 is equal to a quarter. It tells me that if I square root both sides, I get cos theta plus 20 is equal to plus or minus the square root of a quarter, which is equal to plus or minus a half. So I've got two solutions and I need to solve for them both. So if I look first at cos theta plus 20 is equal to a half. Cos is positive here, positive a half, and I know that cos is positive in the A and C section of my CAS diagram. So in a minute I need to use that. So firstly I need to solve and find theta plus 20, which is equal to inverse cos of a half, which gives us 60 degrees. Then I can use my CAS diagram. So C and A are the two sections I need as cos is positive. So my angle is 60 degrees into the A section and 60 degrees into the C section. So 60 degrees downwards, which gives me 2 theta plus 20 is equal to 60 in my range, and theta plus 20 is equal to minus 60 in my range. I'm now going to do exactly the same thing, but this time for my second solution. Cos theta plus 20 is equal to minus a half. So this time I'm looking at the sections where cos is negative, which is the tan and sine section. Again, I need to solve to find theta plus 20, which is inverse cos of minus a half, which gives us 120 degrees. Again, if I draw my CAS diagram, the two sections I'm interested in are the sine and tan. And if I travel 120 degrees clockwise, I reach the sine section, and if I travel 120 degrees anti-clockwise from the zero line, again I also reach the tan section there. So I can draw those on. So my solutions for theta plus 20 are plus 120 degrees, which is in my range, and minus 120 degrees, which is also in my range. However, I'm asked to solve, so that means I need to find theta. So now I've got all four answers in my range. I need to subtract 20 from each one of them, which leaves me with the solutions for theta of 100, minus 140, 40, and minus 80 degrees. And just to double check, make sure all of those are in your original range, which they are. For this last question, I'm asked to solve a quadratic trig equation in the range 0 to 360 degrees. However, this time my trig equation is in terms of both sine and cos, so I need to eliminate one of those variables. And to do this, I use my identity. Sine squared theta plus cos squared theta is equal to 1. As I've got a cos squared theta in the question, I'm going to replace that. So I need to rearrange my trig identity in terms of cos squared theta. So cos squared theta is equal to 1 minus sine squared theta. I can now substitute this in to that quadratic trig equation. So 5 sine theta minus 4 cos squared theta is equal to 2 becomes 5 sine theta minus 4, and then I'm going to substitute cos squared theta for 1 minus sine squared theta, and that still equals 2. I now have a quadratic equation, so I need to expand and rearrange this until it equals 0 before I can try and solve it. So I'm going to expand my brackets to get 5 sine theta minus 4. Minus 4 times minus sine squared gives us plus 4 sine squared theta is equal to 2. And if I subtract 2 from both sides, I end up with 4 sine squared theta plus 5 sine theta minus 6 is equal to 0. I'm now going to let sine theta equal y. So my equation becomes 4y squared plus 5y minus 6 equals 0. I can now factorise this equation to get 4 minus 4y minus 3 and y plus 2 is equal to 0, which gives the solutions y is equal to 3 over 4 and y is equal to minus 2. I've now got my solutions for y, so I need to substitute back in sine theta. Sine theta is equal to 3/4 and sine theta is equal to minus 2. Sine theta is equal to minus 2 will give us no solutions, as sine theta has to be greater than minus 1 and less than 1 or equal to. So for our other solution, we can get theta by inverse sine of 3/4, which gives us 48.6 degrees to 1 decimal place. So I'm going to draw a cast diagram again. I'm trying to solve sine theta equals 3/4, which tells me sine theta is positive. So I should get answers in the all and sine section. So from my horizontal line, if I measure 48.6 degrees into the all section and 48.6 degrees into the sine section, This tells me that my solutions are 48.6, and this angle I find by doing theta is equal to 180. Take away 48.6. Which gives me 131.4 degrees to 1 decimal place. So my solutions in the given range are theta is equal to 48.6 and theta is equal to 131.4 degrees. Now try the questions from textbook exercise 10F on page 221. Do questions 1A to B, questions 1C to G, and then question 2. If you need help, make sure you come and see one of the maths teachers before your homework is due in.